So today we're going to be talking about dimensional analysis and how we can use this in chemistry. Here are our objective and essential question. So at the end of this video, you should be able to convert between units of measurement of grams, moles, and particles by following the steps of dimensional analysis. And the essential question you should try to answer in the summary of your notes at the end of today is, how do we use moles to convert between units of measurement? Again, I encourage you all, as you are watching this video, to pause and record in your notes whatever you need to. When you see this icon on the slide, please take the time that you need to do so. Okay, so the main thing to remember about dimensional analysis is that it is a means of following steps to convert between units of measurement. So just like we know that there are a certain number of inches in a yardstick, we know that an element's molar mass describes the certain number of grams in 1 mole of that substance. So to do this, to convert between these units of measurement of grams, moles, and number of particles, we use these things called unit conversion factors. So our unit conversion factors in chemistry that we use most often are molar mass and Avogadro's number. So those are unit conversion factors. So you will see as we go through these steps to convert between grams and moles, we use molar mass. So if we're starting with units in grams and we want to convert it to units in moles, we will divide by the molar mass. Same thing goes for converting between moles and the number of particles. If we start, for example, with something measured in moles and we want to know how many particles are in that substance, then we will simply multiply by Avogadro's number. In order to do this, it is important to review how to multiply and divide with fractions. So remember, whenever we are multiplying and dividing with fractions, you can flip the numerator and denominator of fractions to multiply and divide. So for example, say we had 1/4 times 1/8. Now in this fraction, we are simply, since we are multiplying, we simply multiply right across the top and right across the bottom. So the next step in this would look like this: 1 times 1. The numerators multiplied together and the denominators multiplied together. So our final answer for this question, 1/4 times 1/8, is 1/32. But let's say we had 1/4 divided by 1/8. Now in this case, what we're actually going to do first is flip the numerator and the denominator of whatever fraction that you are dividing by. So that leads to actually 1/4 times 8/1. Now, we can actually reduce this and cross multiply a bit. So 8 and 4 have a common denominator here, and I'm actually going to do this in a different color. 8 and 4 have a common denominator, and that is actually 4. So if we cross multiply and divide both of these by 4, then you get 2 and 1 here. So now if we're multiplying across the numerators and multiplying across the denominators, we're going to have 1 times 2 in the numerator and 1 times 1 in the denominator. And that gives us a fraction of 2 divided by 1. And remember, any fraction that is a number divided by 1 is really just that number in that that number in that numerator. So that gives us an answer of 2 for 1/4 divided by 1/8. So we're going to use this same principle when we are completing our dimensional analysis problem. So in this example, it is asking for how many atoms of pure carbon are in 3 grams. So what this is really saying is, if we were to draw out this scenario, say we had a bag of carbon atoms and it on a scale weighed 3 grams. So what we're trying to figure out is how many atoms of carbon are in that bag. So the first step that we need to take in this dimensional analysis problem is determine the starting unit and write in the numerator of a fraction over 1. So this problem says that we are starting with 3 grams of carbon. So I'm going to write 3 grams of carbon over on this side, and I'm going to put that in the numerator of a fraction over 1. Following the second step, it says to determine the ending unit and write in the numerator of a fraction over 1, leaving space between the 2 fractions. So basically what I'm doing here is I'm creating some bookends. So I want to get to my final unit, which is asking about the atoms, or I'm going to call this the number of particles of carbon over 1. So I've got my 2 bookends here. I've got the starting unit and I've got the ending unit, both in the numerators of fractions over 1. Now, my next step is to multiply by unit conversion factors to cancel out the original units and get to my final unit. So I'm going to do the same idea and use the same idea of flipping those fractions, whatever's in the numerator and the denominator, to make my math a little bit easier and begin to cancel out those units. So in this first example, we are actually making 2 hops here. So we are starting with grams and we need to get all the way over to number of particles. So I need to kind of make a little pit stop at moles. So what I'm going to do first is I need to convert from grams to moles, and I'm going to use the molar mass of carbon to do so. So normally I would be dividing by the molar mass of carbon, but to make my math a little bit simpler, I'm actually going to multiply by 1 divided by the molar mass. So our molar mass of carbon is about 12 grams of carbon. So I'm going to actually do this in a different color so you all can see this a little bit better. So I'm using the molar mass, and remember our molar mass is always measured in grams per mole. So instead of dividing by grams per mole, I'm actually going to multiply by moles over grams. So I'm going to say 1 mole over 12 grams of carbon. Now this is carbon's molar mass. It is still saying that 1 mole of carbon weighs 12 grams on a scale. What this actually allows me to do is cross multiply and cancel out the units of measurement of grams. So I'm going to cross those out. And now I am left with moles in my numerator. So I have crossed over from grams to moles at this point. Now I'm in units of moles, but I still got to make another jump to particles. So I'm going to actually multiply by my next unit conversion factor, which is Avogadro's number, in order to make that jump. So we know that 1 mole is always going to be equal to 6.022 times 10 to the 23rd particles or units of that thing. This time I'm going to be looking to cross multiply and cancel out moles in order to get to number of particles. So I'm going to say that 1 mole of carbon is equal to 6.022 times 10 to the 23rd particles of carbon. And I'm just going to write C to indicate that that is particles of carbon, mostly because I'm running out of room. And I want to make sure that you all see this math work out. So go ahead and take a moment after I cancel out these units. So I have now made the jump over from moles, and I am in my desired units. Remember, I said I wanted to get to particles. I am now in particles over here. So I've made the jump from moles over to particles. So now all I have to do is simply multiply across the numerator and the denominator to get my final answer. So I've canceled out units of measurement, but what I have not canceled out are these numbers here. So if I were to put these together in one fraction, I would have 3 times 1 times 6.022 times 10 to the 23rd. And I'm going to put that in parentheses to remember my order of operations, PEMDAS. And on the bottom, I'm multiplying 1 times 12 times 1. So if I were to, I'm going to give you all a moment to plug this in your calculator and see what answer you get. Remember, following the order of operations, PEMDAS, so you plug this in your calculator here. So if you plug this in your calculator correctly, you should have gotten a final answer of 1.506. I'm going to round up to 06 times 10 to the 23rd particles of carbon. I'm going to box that in as my final answer. So again, the key with dimensional analysis is doing this cross multiplication in order to cancel out those units of measurement. So every time you see a unit here on the top diagonally across from a unit of the same unit of measurement on the bottom, you can actually cancel those units out. So I canceled out grams and made the leap over to moles. And then I canceled out units of moles and made the leap over to number of particles. Then I multiplied all these numbers in the numerator together and divided them by the numbers in the denominator. And I got my final answer of 1.506 times 10 to the 23rd particles of carbon. I hope this video helps and gives you a good introduction to using dimensional analysis to convert between units of measurement. And I look forward to discussing this with you more in class.